Okay, so I like to assign this problem because it's a great example of the idea of overcounting and then subtracting if you've counted too much. Sometimes it's easier just to count something and say, okay, and what do I have that's extra that I can take away? So for example here, they want us to count straights, 5 cards of consecutive denominations, ace through 5, 10 through ace, whatever, not all of the same suit. Note, they cannot be all of the same suit, but we're going to count them up. How I'm going to start this off is just, what if I'm just going to count anything, same suit, different suits, don't care, we'll take care of it at the end. So the idea here, first thing we're going to do is just, I always like to say take care of your restrictions first. So we know it's a straight. How many different kinds of straights are there? Well, if we make a list, it's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. Now, ace goes on both ends because they show you ace can be low or ace can be high. So how many different straights are there? Well, 5 cards. So it's going to be ace through 5, 2 through 6, 3 through 7. So essentially, we're starting down here. So 1, 2, 3, 4, 5, 6, 7. Because these could keep going to make 5 cards. Where do we run out? Well, the last one we could do would be 10 and ace. If you went up to a jack, there would be nowhere for it to go. There was not enough cards. So there are 10 different kinds of straights. So for our choices here, first thing we're going to do is pick the type of straight. So out of that, straight, there we go. Out of that, that's going to give us 10 combinations of 1. So out of those 10 different, we're going to need 1. So now, when I do this a lot in class, or when I do this with students, I always say, okay, now someone, the divine power, somebody all-knowing has whispered to you, it's going to be a 6 through whatever. Okay, so you say, okay, you've now been whispered into your ear. You know you're going to have a 6, 7, 8, 9, 10, and there you go. You know that's your straight, but there's something you don't know. What type of cards are they? So now we need to pick the cards. So pick the type. So we're going to pick, or the suit would be the other names. So we're going to pick the suit. Now, for the 6, we need to pick its suit. So for the 6, there are 4 different suits, and we're going to pick 1. Then for the 7, there's 4 suits, and we're going to pick 1. For the 8, same thing. So we're going to end up doing this 5 times. So, or the easier way would just be, say, okay, it's going to be the same thing times itself 5 times. We have math notation for that. It's just raised to the 5th. So now we have our suits taken care of. So the total number of possible straights just comes from those 2 things right there. We're going to have 10, pick 1, so we know the type. Then we do 4, pick 1. So now we know the suit for each of these, because we're going to do that 5 times. Is there anything else we need to know? Well, we've overcounted, because in what we've done here, we have, let's say, the 6 of hearts, 7 of hearts, 8 of hearts. We have the one, we have the case where they're all the same suit. So now what we need to do is take away those extras. Now the good news is it's actually a really easy counting problem that's very similar. First thing we do, for the case where they're all the same suit, the ones that we've overcounted, the first thing we have to do is say, all right, how many different straights are there? Same logic, 10 choose 1. Now we need to say, okay, now we're going to pick the suit. Once someone has come down and whispered the type of straight you're going to have, now we're going to say, well, we have to pick the suit. And how many times do we need to pick the suit? Well, we can pick it for the 6, but if you know we're trying to subtract away all the extras, all of these all have the same suit, because that's what the problem says we can't have. So if we know they all have the same suit, once you pick one of the cards, you got them all. So essentially you're saying pick the suit for all the cards. So there you go. So that takes care of that. And what you'll see here is this one usually makes a little more sense, because 10 combinations of 1, that's 10. 4 combinations of 1, that's 4. So that means there are 40 different types of straight flushes. A flush is when all the cards are the same suit. And you can kind of count that up if you think about it logically. So then you can see this one's a little bit bigger. This one's going to be 10, and then 4 combinations of 1 is 4, but it's 4 raised to the 5th, so that's 4, so it's a bigger number. So clearly, you will see it's much bigger than what we're subtracting. I believe this is 1024, if I remember correctly. So that would be, just tack on the 0. So There we go. So I am seeing, or at least I'm thinking, this would be 10,200 different straights. I hope that makes sense. I hope that helps. But the biggest thing to understand here is the logic sometimes. And the logic, what I want you to get out of this is, well, counting up this was relatively easy. Counting up just all the different ways of getting a straight and disregarding whether they're the same suit or different suit. And then subtracting away what we overcounted, because that's also easy. It would be very difficult to count this up with the keeping in mind that they can't be the same suit. That would have been very difficult to do straight off. So hope that helped.